Okay, so I've graphed a function here. That function is f of x equals 2x plus 3. We're going to look at how we go about translating this graph and what the effects of, say, having f of x plus k or maybe f of x minus k. We're going to look at what these k values here will do to our graph, okay? So let me erase that so we have a little bit of space. And the actual function here, the 2x plus 3, we don't even really need to worry about this part right now. We're mostly just concerned with this f of x. Because all I need to know, let's say I want to graph f of x plus 2. I'm going to take my original f of x function and I'm just going to take every point. So here's a point on that graph. I'm just going to move it up 2 spaces. And I'm going to plot that point. I'm going to take a point down here, move it up 2 spaces. Everything at each point gets moved up 2 spaces. It will have the same exact slope, but every single point on the graph moves up 2 spaces. So when I add to it, I'll get a graph that's parallel, but everything, each of these points, let me plot a few more points here so I can graph a straight line. It just gets moved, it just gets shifted up by 2, all of these points. On the other hand, let's say I want to graph f of x minus 2. I'm going to take each point on the graph and I'm now going to bring it down 2. I'm going to take another point and I'm going to bring it down by 2. Take another point and bring it down by 2. So all I'm doing is essentially moving this whole line down by 2 and I'll get a graph. So it should go through the point there, but the idea is that all the points on the graph, the x value doesn't change, but they just drop straight down by 2. So that's what the k value here does, whether it's negative or positive, whatever it is, it's just going to shift the graph up if it's positive and down if it's negative. Not to the left, not to the right, just up or down, and the slope of the graph will stay the same.